Hello and welcome to Martin Maths. We're doing a question about some straight lines and talking about the gradient to find out which is the steepest. So if you know the formula y equal to mx plus c, we're looking at that value m, the coefficient of the x. That's the key word here. The number in front of the x value. So we have y equal to 2x plus 1, y equal to minus 3x plus 3, y equal to minus 5 plus 5x, y equal to 10 plus a quarter x. So we just want to look at the gradient, the coefficient of x. So I'm just going to underline them there. This one I'll try to catch you out by actually putting it at the second term, and this one here. So we want to know which is the steepest, which has the biggest value. So I'm actually going to ignore all the intercepts. I don't need to know about them. I just need to know the coefficients. So 2 is quite steep, but it's not as steep as minus 3. Now you might think that that's negative, but actually it's a downward slope, so it can still be very steep. So that's actually steeper than that one. But 5x is steeper than that, and it's definitely not a quarter x. That's quite a low value. So you think about every one step in the x direction, how much is it going up in the y direction? And the steepest there would be that one. Now, if we're not so sure, let's have a look on Desmos. I really like this website. So I've plotted all 4 of those. Y equal to 2x plus 1, y equal to minus 3x plus 3, y equal to minus 5 plus 5x, y equal to 10 plus a quarter x. And that's what it's showing us there. And we should be able to see that the steepest one is this green line here, which is the minus 5 plus 5x. And in fact, what I could do is I could get rid of the intercepts, make them all go through the origin just to look at the gradient itself and see which is steepest then. And as I say, that one there with the 5x, the coefficient of 5 there is going to be the steepest. And also it shows us that although that's a negative 3, it's still steeper than the 2x. Okay, so that's one question done about which is the steepest graph, which is the steepest gradient, which is the biggest coefficient, and it's that one there. Okay, we're going to look at another question now with this other mini whiteboard. And it's going to ask us which of these is non-linear, so which is not a straight line. And we've got y equal to 2 over x. Should clear all the other things. Y equal to 2 over x, 2y equal to x plus 4, 10x equal to 5, 4x minus 2 equal to y, and x squared minus y squared equal to 25. So 5 different graphs. What we're looking at here is where's the relationship all of the same power, as in, do they have the same power, same exponent, so they'll be linear. And we can see that one is very much in the form y equal to mx plus c. So that is a straight line. This one here, it might not look it straight away, but actually, if you wrote this first, y equal to mx plus c, that's also going to be a straight line. They're both to the power 1. This one doesn't have a y. It means actually just a straight line, but a vertical line, and we'll look at that in a second. So meaning that these two here are the non-linear. Their relationship is not a straight line. They are non-linear. Okay, so we've got, actually that's a power x to the minus 1. If you use your reciprocal index law, you're going to bring that power up. And that one there is actually going to give us a parabolic function, also a non-linear function. Let's look at that visually again on Desmos. So I've plotted all of them here. Y equal to 2 over x, 2y equal to x plus 4, 10x equal to 5, 4x minus 2 equal to y, and x squared minus y squared equal to 25. So I've got all of them there. It might look a bit complicated if I go through each of them. This blue one here, that's definitely a straight line, so I'm actually going to get rid of that one. that purple one there is definitely a straight line. So let's get rid of that one. And this one here is a vertical line, so I can get rid of that as well. And you can see the two that are non-linear are the reciprocal function here, and then the x squared minus y squared. What's interesting to see is if I change that to a plus, you get a nice circle. Also non-linear. Okay, so that answers that question, that the two functions that are not linear are y equal to 2 over x and what was x squared minus y squared equal to 25. Right, there was one more question in this worksheet, which is to find the midpoint of 2, 6, and 9, 10. Now, there is the midpoint formula, which you can use, but I find for some students that involves quite a lot of extra algebra. But if we just think about them in pairs, what's between 6 and 10? And almost intuitively, you'll know that if you were to draw it on a number line, sorry, this pen's certainly not working. You got 6 there, 8 there, and 10 there. You can see that 8 is in the middle. So you know the midpoint is going to go through something and 8. So its y value is definitely going to be 8. And then for the x value, maybe here you would want to use the formula, which is just a mean average. So what you want to do is add the two together, 2 plus 9, 2 plus 9, and divide that by 2. It was much easier to see the y value because 6 and 10, they're both even numbers. I can plot them. The difference is just going to be 4 and halve that. And I can see that 8's in the middle. This is slightly different. 2 plus 9, it's 11. The difference is 7. So I have to actually get 5.5 as the midpoint. Maybe in that case, I do need to use the midpoint formula. Okay, and again, I'll just plot that just to see it on Desmos. So we've got the 2 points there. And if I add in an extra point, which we now know is 5.5 and 8, and then I could label it M or something, but we can see neatly between 6 and 10 was the midpoint there. Scroll that down a bit. Yeah, you can see 8 lies exactly between 6 and 10, and between 2 and 9 was 5.5. Okay, so that was steepness with gradients, linear and nonlinear functions, and the midpoint formula. Thanks for watching. Don't forget to like, subscribe, and share.